So in this lecture, as I said, we'll be discussing applications of FNet equal to MA. Let's begin with a simple question. Assume there is a flat horizontal surface and imagine there is a block on it. Assume the mass of the block is some 2 kg and let's say it is at rest. That's all. The surface is smooth. Okay. We have not discussed anything about friction yet. We know that there is a force called friction, but we have not discussed anything else about it. So let's not bring friction into the equations yet. So there's a block kept on a smooth horizontal surface. It's at rest and we leave it. Vanilla, tell me, what will happen to this block after it is released?
It will slide down, sir.
Down, which way is down?
అంటే ఎటు పక్క తోస్తే దానికి ఆపోజిట్.
We are not pushing it in any direction. We just left it there. We gently placed it there and left it. So what will happen?
It will not move, sir.
Okay. See, there is a reason I asked this question. What will happen to the block? Means you have to predict what happens to a system. Okay. Not just in this question, in any question, if you have to predict something about a system, like if you have to find out its velocity after some time, if you have to find out the distance covered in some time or velocity after some distance, anything, if you want to tell what happens to a system in future, okay? Tell me, what changes the state of a system? Or what
Any
can
force acting on it, sir.
Forces, correct. Forces can change the state of a system. So if you ever come across a question where you are asked to predict something about a system, the first thing you need to consider is the forces acting on the system. Based on forces only, you can tell what happens to it. Okay. So this question can be answered by considering the forces acting on the system about which you are asked. Okay. Now tell me, it's a block which has some mass. It's kept on a smooth horizontal table. What all forces act on this block? Saket, tell me the forces acting on it.
Sir, gravitational force and normal force.
Okay, gravitational force exerted by the earth, we call it as weight of the object. How is weight calculated?
Mass into acceleration due to gravity.
Mass into acceleration due to gravity. So weight of this block becomes 2 into 10, 20 newtons. Okay, what other forces act on it? You said one more force, right?
Normal, sir.
Normal force. Okay, what exerts normal force on the block?
Smooth surface.
The surface. Okay, it's like due to gravity, the block has a tendency to fall down. So it will be pressing the surface. Block exerts normal force on the surface. Surface exerts normal force on the block. And normal, as the word suggests, it has to be perpendicular to the surface. Surface is horizontal, so normal force will be vertical. Let's call it as normal reaction force. Okay, these are the forces that act on it. We have a definite formula for weight. Okay, weight is calculated as mg, so we could tell how much the weight is. There's no fixed formula for normal force. There's no fixed formula for tension also. Okay, do any of you think there could be some other forces acting on this block? No. Okay, these are the only forces acting on it. Fine. Now, if you see, both forces are vertical. They are in the y direction. Forces are vector quantities, direction matters. If both forces are in the vertical direction, y direction, will they have any x component? Will any of these forces have an x component?
No, sir.
No, they will not, because a vector in the y direction makes 90 degrees with the x-axis, and a vector will never have a component in a perpendicular direction. Okay, like weight component, if you want to take along the x direction, horizontal direction, it will be 20 cos 90. Cos 90 is 0. So gravity has no component horizontally. Similarly, normal force in this case, it's vertical. It won't have any component horizontally. Okay. Since there is no force in the horizontal direction, okay, I can write like this. F net in the x direction is 0. And if net force is 0, we had discussed this in the last class. We know F net equal to ma. If F net is 0, A is going to be 0. Means acceleration in the x direction will be 0. And this we can tell from everyday experience also. If the surface is perfectly horizontal and if you gently place an object on it, you won't see it sliding away. It will stay where you put it. Okay. So the equation also proves the same. Acceleration in the x direction is 0. Okay. What about the y direction? Can any of you tell me what will happen to this block vertically? Will it stay there itself or will it move vertically? It is simply placed on a horizontal surface and released. So will the block stay there itself or will it move in the vertical direction?
It will stay there.
Okay, Pawan, how did you tell for sure that it's going to stay there?
సార్ బ్లాక్ అంటే రెస్ట్ ఉందన్నారు కాబట్టి నార్మల్ రియాక్షన్ ఇంకా ఎంజీ ఈక్వల్ అవ్వాలి.
See, it was at rest when we released it. After that, what happens is what we need to predict now. ఓకే, మనం రెస్ట్లోంచి వదిలిపెట్టినాం దాన్ని. అది రెస్ట్లో కంటిన్యూ అవుతుందా లేదా అనేది చెప్పాలి నువ్వు. Okay, anyone else? Can you tell what happens to this block?
Sir, it will continue in rest.
It will continue to be at rest. Saket, how are you able to tell that? Are you telling that based on some equation or are you telling that based on your daily life experience?
Sir, not both, sir. Just common sense.
Common sense comes from everyday experiences only, no?
Yes, sir. Yes, sir.
You must have observed every day that objects don't jump off from a table. That is how you are able to say that it will continue to be at rest.
Yes, sir.
Okay. So as a fact, we know that when you put an object on a table, it's not going to rise up, nor is it going to fall down. Assuming the table is strong enough, it won't fall down. Okay. We know this from everyday experience. And to solve physics questions, you need a little bit of that also. Now see, to tell what happens to a system, you need to know about the forces acting on it. Based on forces, you can predict. Now, in one case, we did that in this question. Along the x-axis, we knew that there was no force. So we could tell that it won't move along the x-axis. Based on force, we told. Fine. But in the y direction, there are two forces acting, weight and normal force. We know how much is the weight of the block, but we don't know how much is the normal force acting on it. Okay, there is no formula for normal force. We don't know how much normal force is acting on it. But from everyday experience, we know that a block placed on a surface doesn't move on its own. Okay, so what can we conclude from that? We can say that acceleration of the block in the y direction is 0. Okay, if the table is at rest, the block kept on it will also be at rest. It won't move up or go down unless the table moves. Okay, table is not moving in this case. So we know for a fact that acceleration in y direction is 0. And if acceleration in y direction is 0, it means the net force in the y direction is 0 because net force is mass into acceleration. Okay. Now what all forces are acting in the y direction? There is weight and there is normal reaction, normal force. Now we have concluded that the net force in the y direction must be 0. So weight must be balanced by normal force. And now you can tell that the normal force also must be equal to 20 newtons. Fine. So along the x direction, based on force being 0, we said acceleration is 0. But along the y direction, we are doing the reverse. We know that acceleration in the y direction is 0. Based on that, we calculated one of the unknown forces. Fine. So to solve physics problems, you need both. Okay, based on equations, you should be able to tell what happens to a system. And based on your knowledge of what happens to a system, you should be able to frame equations. Okay, that is also important. So as I said, there's no formula for normal force or tension. Depending on how a system behaves, you will derive those forces. You will calculate those forces. Okay. Fine. Let's consider another system. Block, assume its mass is 5 kg. And let's say it is supported by 2 strings. Okay. Tell me from your everyday experience, is it possible to support an object by tying it to 2 strings like this or not? What do you say?
It's possible, sir.
It's possible. We can fix a system like this, fix an object like this. Have you seen any object suspended like this in real life? Ever? Okay, it's quite possible that you have not observed anything like this. Happens. So let this angle be some 53 degrees. This angle be 37 degrees. And the block is supported this way. It is possible to support it. Aishwarya, can you tell me what all forces act on this block?
Sir, tension force.
Okay. What did you say? Tension and? I could hear only tension. What other? Did you mention any other forces?
Sir, no, sir.
Okay. Which way does tension act according to you? In which direction do you think it acts?
Sir, upward.
Aishwarya, can you tell something about tension? Like, when is this force tension generated, and usually in which direction does it act? Not in this question, but generally, how does tension get generated? Anyone?
Sir, it's like
Hmm.
restoring force that acts when objects are stretched or something.
Correct. So when some material tends to get stretched, the restoring forces, the chemical bonds inside the material, they maintain its shape by pulling the molecules together. Okay, that pulling force is what we call tension. Okay, here there are 2 strings. Let's call them as S1 and S2. And now, like, suppose we cut off S2. Let's say we remove this string. What will happen to the block? Will it stay there itself, or will it move away from that position?
It will move away.
Any of you can answer. It will move away. We, from everyday experience, we don't see a string staying in that slant position on its own. Aishwarya, you tell me, what makes the block move away? And which way does it move? You tell me first. I'll give you some options. Like, will it go like this? Will it fall down like this? Will it go to this side? Will it move up? Choose one.
Sir, towards A.
Along A. Okay, we know it swings this way. Now you said tension was the only force acting on it, and you said tension was acting upward. Then what makes it swing down like this? I mean, down and left. What makes it go this way? Anyone else? Once the second string S2 is cut, what makes the block move?
Sir, there's no tension of the string acting on it anymore, so it just moves away because there's only one head left.
Why does it choose this direction? And why not this or this?
Sir, gravitation force.
Gravity. Because of gravity only it starts moving. Okay, I'm telling this to you all in general. If an object has weight, it will if an object has mass, it will have weight. Weight is the first force that you will consider. Okay, whether the strings are there or not, mass is there, gravitational force will be there. Fine. So let's indicate the forces acting on the block. One force is its weight, calculated as mg 5 into 10, 50 newtons is the weight of the block. Right. Okay, now I hope you all are sure that when one of the strings is cut, the block starts moving away. Means before being cut, before the string is cut, the string is somehow supporting the block. Okay. Now from everyday experience, you tell me, suppose there is an object. Okay, imagine this is on a table. Assume this is the table surface. You are viewing from top. Okay, so this is the top view. Let's say there is a block kept on it. And there is a string tied to it. And it's straight. The string is straight. You are holding it here. Okay, so the string is parallel to the table. Now tell me, when the string is in this position, in which direction can you make the block move by, I mean, you are holding the string. So tell me, in which direction can you make the block move? I'll give you some options. A, B, C, D, E, F, G, H. The block has a string connected to it and you are holding the string straight. Okay. Now do whatever you want to do with the string. In which direction can you make the block move from this position?
Sir, towards it.
I got one answer as any direction is possible. We'll discuss that. Pawan is saying only A is possible. Okay, you all can try this also if you want. Just tie a stone to a thread and try. Okay. Pawan, tell me, why only A? Like, are you sure it is only A?
సార్ మనం మన సైడ్ లాగలుగుతాం కానీ వేరే డైరెక్షన్ ఎలా చెప్పగలుగుతాం? యాంగిల్ మార్చి లాగితే వస్తుంది.
Correct. What he's saying is, string can pull in the direction of the string. How can it make an object go in some other direction? And he also said that if we change the angle made by the string, then it can be dragged in that direction. Okay, that's correct. What he said is correct. And you all think about this on your own. Can you push an object with a string? You can pull, you can tie the string to the object, or you can somehow attach it and pull. Can you push with a string? Rishi, what do you say? Can you push something with a string?
Sir, it's not really possible. Like you can push it, but like it's more, you can just pull it, it's easier.
Okay. You can pull using a string with a greater force. If you try to push something with a string, some objects may get pushed by a string also. For example, small bits of paper, you can push them with a thread because thread has a little bit of rigidity. Okay, you can push them, but the pushing force is not much. For example, if there's a heavy object, like slightly heavy also, like maybe a pen, I don't think you can push a pen with a thread. Okay, the common thread we use, cotton thread. I don't think pushing a pen is possible. Pulling is possible. You can tie and pull. Okay. So see, in your course, we are going to assume that a string cannot exert any pushing force at all. Okay, strings cannot push. If you try to push something using a string, it will become slack. Okay, it won't remain straight. The string will get bent, but it won't be able to exert any force. That is how we are going to assume. In a real life situation, little bit of pushing is possible. Okay. And it also depends on the nature of the string. Now, some of you, like you take the charging cable of a mobile phone. It has a little bit of stiffness. Okay, you can call it a rope if you want, but it has a little bit of stiffness. You can push, maybe you can push a pen also with a charging cable. Okay, it's stiff enough to push a pen. Okay, but we are going to assume that strings cannot push. Okay, we will take strings which are very easy to bend. And one more thing, you cannot exert force using a string in any direction other than the direction of the string itself. Okay, so strings can only pull, and they can only pull in their own direction. Fine. So basically, we will not consider a string to have any kind of stiffness in any other direction. Only along the length of the string, that too while pulling, it has stiffness, it maintains its shape. If you try to bend a string in any other direction, or if you try to deform a string in any other direction, it freely deforms. Okay, so that is how we are going to consider strings. So the only possible direction in which this block can be moved by the string is this way. By changing the direction of the string, you can change the direction in which the block is pulled. That's possible, but the idea is that in whichever direction the string is, it exerts force in that direction itself. Okay, now come back to the question. There are two strings here connected to the 5 kg block, and we consider them as ideal strings. Okay, so string S2, if it is cut, you know the block is going to move. Means before being cut, it was exerting a force on the block. It was holding the block. How does it hold the block? By exerting a force this way. Let's call that as tension exerted by the second string, T2. Okay, on the block, it will act like this. It will be pulling the block and supporting it there. Similarly, the string S1 will be pulling the block this way. Whatever is the direction of the string, it exerts force in that direction only. Fine. So Aishwarya, is this clear? Tension is acting on the block, but there is weight also.
Yes, sir.
Do any of you think any other forces could be acting on this block? Okay, right. Now, Saket, tell me, where is the reaction to this force?
Towards the earth, sir.
That force is towards the earth. How can the reaction also be towards the earth? Will action reaction be in the same direction?
So sorry, upwards, sir, reaction of force.
What exerts the reaction to this on what?
Normal force, sir.
Normal force.
Yes, sir.
See, without two surfaces pushing each other, there is no normal force. Where are two surfaces pushing each other in this case? Where are surfaces pressing against each other in this case?
Sir, tension.
So you are saying tension is the reaction to this?
Yes, sir.
No. We discussed this in the last class. Action reaction should be of the same nature. What kind of a force is weight? Weight is a gravitational force. Then the reaction to that also should be a gravitational force. Saket, tell me, who is exerting or what is exerting this force 50 Newton on the block?
Sir, the earth, sir.
Earth, no. Weight is the gravitational pull on an object exerted by the earth. Correct. Then if earth is exerting force on the block and you are calling that as the action, then reaction should be exerted by what on what?
Should be
What did you say?
exerted by the block on the earth.
Reaction will be exerted by the block on the earth, and it will also be gravitational only. So block will exert 50 Newton force on the earth, but that 50 Newton force won't affect the earth much. Right. Now, okay, Vanilla, you tell me about this force T2. What is exerting T2 on what?
The block is exerting T2.
On? On what is the block exerting T2?
Ring, sir.
Block is exerting on string in that direction. Block is pushing the string.
No, sir.
Then is the block making the string tight or making it loose?
Tight, sir.
So is it pulling the string or pushing the string? స్ట్రింగ్ టైట్ చేయాలంటే దాన్ని పట్టుకొని లాగాలనా లేకపోతే దాన్ని ఇట్లా కంప్రెస్ చేయాలనా లోపలికి?
లాగాలి, sir.
We have to pull. Okay. But anyway, anyone else, if you can tell, what is exerting this particular T2 that I have shown in the diagram on what?
The string is exerting a pushing force, pulling force on block.
T2 is the pulling force or tension exerted by string S2 on the block. Okay, S2 is pulling the block that way, and block will be pulling S2 in the opposite direction. On that string, there will be a pulling force exerted by the block. That's why the string remains straight. Okay, remaining straight is also called remaining taut. Okay, T-A-U-T. Don't get confused by that word. It just means the string is straight. Okay. So we are concerned about forces acting on the block. We are only showing forces acting on the block, but there will be forces exerted by the block also. Okay. String S2 exerts T2 on the block. Block will be exerting tension on the string. Block will be pulling the string. That we need not show. Why we need not show? Because the question is not asking us about that. Anyway, I have not told you the question yet. The question is to calculate T1 and T2. Tensions in the strings. Okay, but these are some things which students usually don't think about. What is the action, what is the reaction and all, but you better consider those things also. Anyway, it is given to you that the block continues to be at rest. Stable. Okay, so the ropes are strong enough. They are not allowing the block to fall down. The ropes are not getting cut. So this system stays as it is. Fine. That means the block does not get disturbed. In that case, you have to calculate T1 and T2. Okay. One of you quickly tell me, what are T1 and T2? What are T1 and T2?
The vector component.
They are forces. Yeah, they are vectors, but they are forces. Correct. Force vectors, you can say. The only equation we note as of now for force is F net equal to ma. Okay. Now in this question, you are asked to calculate forces. To calculate forces, the only equation we know as of now is this. F net is equal to mass into acceleration. So we have to somehow use this to calculate the force. Now the unknown term is the force here. Then if you know mass and acceleration, then only you can tell the force. The mass of the block is obvious. What is the acceleration of this block? According to the question that I have, according to the situation that has been described to you, what is the acceleration of this block? I told you that the system is stable. The ropes are not, the ropes are strong enough. They're not getting cut. The block doesn't go anywhere. So what is the acceleration of that block?
Zero, sir.
Zero. It is at rest and it continues to be at rest. Means it has no acceleration. So we know the acceleration of the block. Mass is 5 kg, but acceleration is 0. That means the net force on the block has to be 0. Okay. Using that fact, we now have to find out T1 and T2, the magnitudes of T1 and T2. T1 is one force, T2 is another force. T1 is exerted by one string, T2 is exerted by some other string. There's no guarantee that they are equal. Then we have only one equation, F net equal to 0, but we have two unknowns, T1 and T2. Can one of you tell me what can be done? How to get two unknowns from one equation? Or can you just tell me any idea to calculate the forces T1 and T2? Like in the previous question, I'll tell you, we knew that this block's acceleration is 0. From that, we could write weight is balanced by normal force. So we got the magnitude of normal force as 20. There was only one unknown force. One equation was sufficient. But here there are two unknown forces. We have only one equation, that net force is 0. How to calculate T1 and T2?
Sir, linear equation in two variables.
Linear equation in?
Two variables.
But one equation with two variables cannot be solved. Like if you have a plus b is equal to 10, you can't tell a and b. You need one more equation to find out a and b separately. Any other idea, anyone? So let me repeat the question. What are T1 and T2? I repeated the question, you repeat the answer. What are T1 and T2?
The forces.
Forces are what kind of quantities?
Vector.
Vector quantities. And vectors can be resolved into components. Fine. That we have to take advantage of that here. So let us visualize the block and the forces acting on it separately first. I'll remove this diagram. Consider this block. There are three forces acting on it, okay? One of them is its weight. We know its direction and magnitude, 50 newtons. There are two other forces acting on it. One force is tension T2, which acts this way. Another force is tension T1, which acts this way. Okay. This kind of a diagram, which indicates the forces acting on a particular object, is called a free body diagram. Free body means we don't show other objects in this diagram. We only show the particular object which we are interested in, and we show the forces acting on that object. Such a diagram is called a free body diagram. Okay. And you don't have to draw a separate diagram like this. Like once you get used to solving problems, you won't draw separate diagrams. But for now, let us visualize the block separately. These are the forces acting on it. And we know that the net force on the block is 0. Okay. Now we have to solve for T1 and T2. There are two unknowns. So what we will do is we'll make use of their components. We will take their components along x-axis. That will give us one equation. And we'll take components along y-axis. That will give us another equation. And then we'll have two equations, two unknowns to solve. Okay, that's the idea we are going to use. Okay. The angle made by T2 with the horizontal is 37 degrees. If that angle is 37, this will also be 37 degrees, parallel lines, transversal and all. And this side, if the angle is 53, this angle will also be 53 degrees. So 37 degrees here, 53 degrees here. These are the angles made by T1 and T2 with the horizontal, With vertical also you can tell the angles now. Okay. We don't know their magnitudes yet. Let's call them T1, T2 itself. One of you tell me how much will the x component of T2 be, or how do you express the x component of T2? Magnitude is T2, angle is 37. How much will the x component be?
Sir,
T2 cos 37. Cos 37 is 4 by 5. So this becomes 4T2 divided by 5. Okay. From this point, I want you all to do it. I mean, we have taken the x component of T2 now. Similarly, you take the x component of T1. T1's component I'll indicate in yellow. You write the x component of T1. Then you write the y component of T1 and the y component of T2 also. Then what you have to do is, since net force is 0, you will split this. I mean, you will get two equations out of this. You will get net force in the x direction is 0. That will be one equation for you to solve. And then you will get net force in the y direction is 0. That will be the other equation for you to solve. Solving these two equations, you can get T1 and T2. So I'll give you all 2 minutes. Complete this problem. Like solve this completely. So what all do you have to do now? Write T1's x component, write T1's y component, write T2's y component. Then write an equation balancing forces in the y direction, means upward force is equal to downward force. That is the equation. And write an equation balancing forces in the horizontal direction, means rightward forces are equal to leftward forces. Two equations, two unknowns, you'll be able to get the answer. Do this, all of you. Saket, your answers are correct. Good. Others also try to write the equations and solve quickly. Okay, let us discuss. Pawan, tell me, how will you express the x component of T1?
Sir, T1 cos 53.
T1 cos 53. Cos 53 is 3 by 5. So 3T1 divided by 5. Okay. What about its y component?
Sir, T1 sin
Hmm.
53.
Sin 53, that becomes 4T1 by 5. Sin 53 is 4 by 5. So 4T1 by 5. Okay. Vanilla T2's y component.
T2 by 5, sir.
3T2 by 5. Okay. So we have expressed all the components. The only thing we are left with now is to write the equations and solve them. Aishwarya, tell me, how will you write the equation for net force in x direction is 0?
So 3T1 by 5 plus 4T2 by 5 is equal to 0.
Why are you adding them? Are they both in the same direction? See, if you are taking one of them positive, the other should be taken negative. There are two ways to write the equation. You can write net force in one direction is equal to 0. Or you can do net force in the rightward direction is equal to net force in the leftward direction. Okay. So the force acting to the left is 3T1 by 5. It should be equal to the force acting to the right, 4T2 by 5. Because T1, T2 here are only magnitudes. Direction is shown by the arrows. Okay, you can't add two magnitudes and equate it to 0. You can add two vectors and equate it to 0. That's fine. But two magnitudes, two non-zero magnitudes, their sum cannot become 0. Okay. Let me just clarify this point. The way you told the equation, it has to be written like this. 3T1 vector by 5. But again, that will be misleading. I'll tell you why it is misleading. Plus 4T2 vector by 5 is equal to 0. You may have written the equation like this, but this way also it is actually wrong, because T1 vector's actual direction is this and T2 vector's actual direction is this. So 3 by 5 times of this vector added to 4 by 5 times of that vector cannot become 0. They are not in opposite directions. No. Okay. So you should avoid doing that. Understand that T1, T2 here are only the magnitudes of those forces. Directions are indicated by the arrows. So 3T1 by 5 is equal to 4T2 by 5. Another way you can write it is this. If you want to express it as a vector, you should write it as minus 3T1 by 5 I cap. And if you want to express this as a vector, you should write it as 4T2 by 5 I cap. Their sum can be equated to 0. Okay. But anyway, these are all going to make it lengthy. So force acting to the left, its strength means its magnitude should be equal to the force acting to the right. That is the way we are going to take it. So 3T1 by 5 is equal to 4T2 by 5. 5 cancels. 3T1 is equal to 4T2 is the first equation for us. Next, net force in y direction is 0. Rishi, can you tell an equation for this?
Sir, 4T1 by 5 is equal to 3T2 by 5.
Why should these two be equal?
No, sir. 1 second. Sir, it's those both only because they're in the y component.
But they are both acting in the same direction. How can you say they should be balancing each other? How can you say they should be of the same strength?
Oh yeah.
So we need to write an equation for net force in the vertical direction being 0. So generally, like you look at what we did for x-axis. to write an equation for net force in the x direction to be 0, force acting to the right was equated to force acting to the left because they balance.
Yes, sir.
So here in the vertical direction, you have to see what forces are acting upward and what forces are acting downward. All the forces acting upward together balance all the forces acting downward. Based on that, you tell the equation.
Three T2 by 5 is equal.
All forces acting upward balance all forces together acting downward.
Sir, so it's 3 T2 by 5 by 4 T2 by 5. Okay.
Okay. Anyone else? Vanilla, can you tell how to write an equation for net force in y direction being 0?
T1 by 5 plus 3, T2 by 5 equal to 50, sir.
These two forces together are acting upward and this force is acting downward. So the combination of 4T1 by 5 and 3T2 by 5 should be balancing 50. That will be the second equation. So 4T1 by 5 plus, okay, it is acting along with 3T2 by 5, right? So they get added and they both together are balancing the downward force of 50 Newton. Rishi, is this clear?
Yes, sir, it's clear.
So you can send the 5 that side, you get 4T1 plus 3T2 is equal to 5 into 50 is 250. That's the second equation. Now you have to solve these two equations, little bit of mathematics, and you will get the answer as T1 is equal to, I think it will be 40 Newtons and T2 will be 30 Newtons. Okay, that solving you do later. Understand how we frame equations to solve the problem. Okay. And see, I'm telling this to all of you. Generally, when you practice problems, make sure you do all the steps till you get the final answer. Many students, they tend to just see the problem, and if they get an idea, they won't solve it. They move to the next problem. Avoid doing that, because any small mistake in the steps that you do will make you end up getting negative marks in your final exam. Okay, so make it a habit to solve problems completely. Okay, whether it is me or anyone else teaching you or you're learning from somewhere else, teachers will usually give you ideas. It is you who has to apply those ideas and get the final answer, and make sure you do that. Okay, make it a habit to solve problems completely. Because many students, they know all the ideas, but they end up getting less marks in the exam than what they deserve, because they get stuck up in calculations. They're not used to practicing calculations, especially the batches that are passing out these days due to COVID or whatever be the reason. They have, I'm including you all also in that batch only. Generally, they don't have a tendency to put their pen down and solve equations and all. They don't have that much patience, but you have to build that patience because you are expected to solve the equations. Okay, so make it a habit to solve problems completely. Anyway, let's go through this question quickly once again. You were given a situation where a block was stable. It was not moving, and you were asked to calculate some unknown forces acting on that block. Fine. So since the block is at rest and continues to be at rest, we concluded that its acceleration is 0. And if acceleration is 0, net force must have been 0. We are making use of that to find out the magnitudes of the unknown forces. Okay. Generally, if the net force on a system is 0, that system is said to be in equilibrium. Fine. Many times in questions, they just use this term. They say the system is in equilibrium, the block is in equilibrium. It means the net force on that system or block is 0. Fine. Especially, it's called translatory equilibrium. There's another kind of equilibrium also, rotational equilibrium, which we'll talk about 2 chapters later in rotational mechanics. For now, you just consider equilibrium as net force being 0. Okay. So sometimes they will tell you that the object is in equilibrium. Sometimes you yourself have to understand that it will be in equilibrium. From daily experience, you can tell. Okay. So remember this term equilibrium. Equilibrium means net force being 0. Now I have one question for you all. Can an object in equilibrium be moving? Or is it necessary that it is at rest? Think and answer. Is it possible for an object in equilibrium to be moving?
No, sir.
How do you say that?
Sir, the above example, even when 50 Newton is acting on it, because it is strength, it is still in equilibrium and it is not moving.
See, the previous question was a case where the object was not moving. In that case, if the object is not moving, it doesn't mean that no object in equilibrium can be moving, no? That was a case where object was in equilibrium and at rest. Now I'm asking you a separate question. Can an object be in equilibrium and be moving?
No, sir, because all forces will be equal, so net force will be 0.
Don't say all forces will be equal. Net force is 0, correct. Equilibrium means net force is 0. Okay. So it's like the question now becomes, if net force is 0, can an object be moving? And you're saying no. Any other answers?
Sir, yes.
How? Can you give an example?
So like when raindrops are falling, it's pulled by gravity, but then it's like also balanced by the air friction.
Correct. Okay. When raindrops fall by a significant distance, what happens is gravity will be acting downwards. There will be air resistance or air drag acting upwards, and those two will balance. And the raindrop moves with a constant velocity after some time. Initially, when it just starts falling from the cloud, it will accelerate. But after moving some distance, it attains a constant velocity because the net force on it becomes 0. The forces become balanced. But even when forces become balanced, it's moving. Okay. So net force is 0 means acceleration is 0. If acceleration is 0, that means velocity is constant. It doesn't mean velocity is 0. Right? So if an object is moving with constant velocity, then it is a case of an object in equilibrium moving. Saket, is this clear?
Yes, sir.
Equilibrium just means net force has to be 0. But just because net force is 0 doesn't mean the object is not moving. It can be moving with constant velocity. Okay. So an object which is at rest and continues to be at rest is in equilibrium. Okay. Rest and continuing to be at rest means it's not accelerating. Means there's no net force, it's in equilibrium. That is one case of equilibrium. An object which is moving and continues to move in the same manner, that is also equilibrium. Okay. Continuing to move in the same manner means not accelerating, means net force 0, equilibrium. So rest and continuing to be at rest, or moving and continuing to move in the same manner, both are cases of equilibrium. So remember, equilibrium does not imply rest. Fine. Equilibrium only means net force is 0. Whether the object is at rest or moving, you need to know the situation. Okay. Right. Let's solve another question. Again, assume there's a horizontal surface, a rigid horizontal table, okay, strong enough. And this time, let us assume there are 2 blocks kept on it. This is one, it's in contact with the table. And on top of that, another one. Both are placed gently there and the system is released. The upper one, let's say it has a mass of 2 kg. Let's assume it has a mass of 2 kg. Lower one, assume it has a mass of 3 kg. This surface is rigid. Okay, so we have gently placed the blocks there, one on top of another, and really the system is released from rest. Can any of you tell me what happens to this system?
It is in equilibrium.
Okay, it will be in equilibrium, you're saying. So basically you're saying nothing will happen to it. It will stay as it is. Fine. See, we can tell that only after considering the forces. Okay, I told you in the first question in today's class itself, if you ever have to predict what happens to a system, you have to consider the forces acting on the system. Okay. Pawan, tell me, what forces act on the 2 kg block?
The normal force exerted by 3 kg block and
Okay,
gravitation force.
it has contact with 3 kg, so you can expect a normal force to be acting there. In which direction will that normal force act?
Sir, upwards.
Okay, on 2 kg, there will be a normal force acting upward like this. From 3 kg, you said. Okay, let's write it like that. And what other forces act on it?
Sir, mali 2 kg block kuda 3 kg మీద normal force apply
I
చేస్తాం.
am asking what forces act on 2 kg. 3 kg మీద పక్కన పెట్టు. 2 kg మీద ఏమేమి యాక్ట్ అవుతున్నాయి చెప్పు.
Gravitation force.
Gravitational force. You can call it as the weight of the block. Weight of the block, 20 Newton, will be acting like this. Will any other forces act on it?
No, sir.
Okay. Fine, that is correct. These are the only forces acting on the 2 kg block. And they are both vertical. Okay. They are both in the y direction. Next. Vanilla, tell me what forces act on the 3 kg block.
Gravitational force and normal force.
Gravitational force, that is its weight, 3 kg, so 30 Newton weight will be acting. Okay. Let's call it as W2, 30 Newtons. You said normal force. What exerts normal force on the 3 kg block?
The table, sir.
Table exerts, that is correct. Okay, the 3 kg is in contact with the table. See, generally you can take it as a rule of thumb. Wherever there is contact, you can consider a normal force to be acting. Okay, Vanilla, tell me the direction of that normal force by the table on the 3 kg block.
Upward, sir.
Upward. Okay, that is correct only. Table exerts normal on the block in the upward direction. Let's call this as N2. This is from table. That's correct. Are these the only forces acting on 3 kg? See, generally, I'm telling this to all of you. If you want to tell what all forces act on an object, okay. For now, we are only going to consider these 4 forces. What are they? Weight, normal force, tension, friction. Okay. As of now, we are not even considering friction. So the only forces you need to take into consideration are weight, normal force, and tension. weight will definitely act. We are considering objects near Earth, so weight will definitely act. There's no choice. Okay. When to consider normal force? Whenever there is a surface of contact. Okay. How many ever surfaces of contact are there? Those many normal forces will have to be considered. Wherever there is contact, you consider a normal force. And wherever there is a string or a rod connected, you consider a tension to be acting. Here, in this case, there are no strings or rods, so no need to consider tension. Normal force is what you need to consider. So Vanilla, now you tell me, are these the only forces that act on 3 kg?
No, sir.
What else will act on it? You have considered its weight.
2 kg block
Hmm.
will act tension on 3 kg blocks.
Tension is a pulling force. అంటే 2 kg 3 kg ని పైకి లాగుతుంది అని చెప్తున్నాం.
Not tension, sir.
Does 2 kg push 3 kg or pull 3 kg? Does it press or pull?
Press, sir.
Pressing is pushing. Okay. And pushing means normal force. So 2 kg exerts normal force on 3 kg. Okay.
Okay, sir.
And in which direction will it exert that?
Downwards, sir.
Downwards. Correct. So let us look at this from an action reaction point of view. On 2 kg, 3 kg is exerting a normal force. Okay, this one. Let me indicate that in yellow. Let's consider that as an action exerted by 3 kg on 2 kg. Then there should be a reaction exerted by 2 kg on 3 kg, no, downwards. Okay, that will be there. So I'll indicate that in yellow itself. On 3 kg, there will be a normal force acting downwards. And that comes from 2 kg. I mean, that is exerted by 2 kg. And these two should be of the same strength. So if you call this as N1, then this will also be N1. Action reaction have the same strength. That is how it happens in nature. Okay, it's a law. So you'll just have to take it for granted. So whatever N1 acts on 2 kg in the upward direction, the same N1 acts on 3 kg in the downward direction. Next, what are there any other action reaction pairs that we need to consider? N2 is from table on 3 kg, and 3 kg will exert N2 on the table. That is not of any importance now. We are not considering forces on the table. We're considering forces on the blocks. Okay. So when you write all the forces acting on the blocks, you see that there is an action reaction pair in that set of forces. So action reaction should be of the same strength. So we can take advantage of it and simplify the equation. How is it simplifying the equation? See, we know there is a normal force acting on 3 kg. Instead of taking it as a new force, N3, you can call it N1 itself. Magnitude wise, it will be equal to N1. That way it simplifies the question a little bit. Simplifies the solution a little bit. Okay. Are you all convinced that these are the forces acting, or are there any other forces acting on through a 2 kg or 3 kg? We considered their weights. Wherever there is contact, we wrote a normal force. There is no chance of tension here. There is no friction here. So we have considered all the forces. This is how you confirm for yourself that you have taken all the forces. Okay. Now you can see that all the forces are vertical. So horizontally, there are no forces at all. That means horizontally, the net force should be 0. And if horizontally the net force is 0, it means horizontally the acceleration will be 0. These blocks are not going to move sideways. Okay, there is no chance of them moving sideways. Okay, and will they move vertically? That we have to tell from our experience. We know they won't move vertically. We won't see blocks rising up on their own, no, when you keep them on a table. Okay, that means acceleration in y direction is 0. And from that, we can conclude that the net force in y direction is 0. Okay. So like, why can't we conclude based on the forces? Because we don't know the magnitude of these forces. We don't know how much is N1. We don't know how much is N2. So we can't directly tell that the net force in y direction is 0. But based on the fact that the blocks are not accelerating that way, we can tell that the net force in y direction is 0. Okay. So x direction force is 0, y direction force is 0. System is in equilibrium because the total force is 0 now. Okay. Calculate N1 and N2 quickly, all of you. Directly by looking at the diagram, I think you can tell. Total force on each block is 0. So tell me how much are N1 and N2. I got one answer for N2 as 30. N2 30 is wrong. Pawan Venala, your answers are correct. You just have to write equations balancing the forces. So all forces acting upward must be equal to the sum of all forces acting downward. That is the way you need to write the equation. So by looking at the first block, Rishi, tell me how much is N1 based on forces acting on 2 kg.
Sir, it'll be, sir, 1 second, I'm not so sure.
The forces on 2 kg should be balanced. One force, 20 Newton, is acting downwards. Then how much
Yes,
is the
sir.
upward force?
N1 is
It has to balance the other force. So how much should it be?
sir, it should be 20 only.
That's all. It should also be 20 Newtons. Correct. Okay. Now the same amount of N1 acts on 3 kg in the downward direction. So there is a 20 Newton pressing 3 kg down. And along with that, there is its own weight, 30 Newton. Saket, tell me how much should N2 be?
50, sir.
The total force acting downwards on 3 kg is 30 plus 20. So the force acting upward on 3 kg should also be 30 plus 20, that is 50 Newtons. So N2, the normal force exerted by the table, is 50 Newtons. You could have answered it this way also. The table is bearing this entire weight of both the blocks. Both the blocks together become a 5 kg mass. Table is supporting 5 kg mass, means table is supporting a weight of 50 Newtons. Okay, that way also you could have directly told that N2 is 50. Okay, do any of you have any questions in this? Okay, fine. Let's take another question. Suppose there is a okay, let's say there's a groove like this. These questions are quite common actually. Just a moment. So imagine there is a V-shaped groove in which an object is placed, a round object. Let's say a ball is placed in that groove. Okay, tell me, can the ball be supported there or not? If there's a V-shaped groove like this, can you put a ball there and expect the ball to stay at rest? Is it possible or not?
Yes, sir.
It's possible it can stay there. Okay. So assume the angle on this side is 30 degrees. Other side is, okay, 60 degrees. Assume the mass of this ball or sphere is say 5 kg. A heavy sphere is supported like this. One of you quickly tell me what all forces act on the sphere. What all forces act on the sphere?
Sir, normal and gravitational.
Okay. Weight will definitely be acting. How many normal forces will act on it? Only one or more than one?
Sir, 2.
See, as I said, wherever there is contact, you have to consider a normal force to be acting. Now this sphere is in contact with two surfaces. So you have to consider two normal forces to be acting. Let's name them as N1 and N2. Normal force, as the name suggests, normal means perpendicular. It has to be perpendicular to the surface. So there'll be one normal force acting like this. Call this N1. Another normal force acting like this, call this N2. And its weight will be acting. Weight acts vertically downwards, we know that. Okay. We know its weight. Okay, weight is mg, so 50 newtons. So the sphere is in equilibrium. Okay, you are told that it's in equilibrium. Calculate N1 and N2. Do this quickly, all of you. There are two unknown forces that you need to calculate. What does equilibrium mean?
Net force is 0, sir.
Net force being 0, correct. So you have to make use of that and derive the unknown forces. So the first thing you need to do is draw the free body diagram. Means just imagine the sphere separately and draw the forces acting on it with their tails at the same point. Okay. So these three vectors, you draw them with their tails at a common point. Then write equations. Equations for net force being 0. Do this quickly, all of you. I'll give you 2 minutes. Any answer, anyone?
Sir, N1 25√3, N2 25.
Okay, 25 and 25√3 you're saying. Let's see. Others, any answers?
So same answer.
Okay, I
Same
think that is
answer.
correct only. Good, good. Let's visualize the forces first in the free body diagram. And since there is only one equation, and I mean, it looks like there's only one equation, F net is 0, but there are two unknowns, no? So we make use of the fact that forces are vector quantities and that we can separate them into components. And to take components, we need x-axis and y-axis for reference. Okay. One of the forces acting on the sphere is its weight. Its weight was acting this way, 50 newtons. And the other forces acting on it were N1 and N2. N1 acts tilted to the right, N2 is tilted to the left. But to exactly calculate the forces, we need the angles at which they act. So imagine a horizontal here. Imagine a horizontal here also. If this angle is 60, then the angle on this lower side is going to be 60. Then the upper side angle is going to be 30 because N1 is a normal force. Normal means the total angle is 90. So if one part of the angle is 60, the other part has to be 30. Now N2, 30 degrees here means 30 degrees here means 60 degrees here. So N1 makes 30 with the horizontal, right side, and N2 makes 60 with the horizontal to the left. So you can indicate N1 like this. Making 30 degrees. And then you can indicate N2 like this, making 60 degrees. That is the free body diagram now. Okay, there are two unknowns, so we need two equations. We split the vectors into components. N1's horizontal component will be N1 cos 30. Cos 30 is √3 by 2. So this becomes N1 √3 by 2. And its Y component, you can call it cos 60 or sin 30, 1 by 2. So it becomes N1 by 2. Those are the X and Y components of N1. Once you visualize the components, you need not consider the original force anymore. In fact, you should not consider the original force anymore. You either take the force as it is, or you take its components. You can't take the force and also its components. Then you'll be doubling the force. Okay, that should not be done. Similarly, N2's components. N2 has a component to the left. Angle with the leftward direction is 60. So N2 cos 60, that becomes N2 divided by 2. The other component in the Y direction, with y-axis it will make 30 degrees. So N2 cos 30 will be the component. Cos 30 is √3 by 2. So N2 √3 by 2. That's all. These are the components. Now balance the forces. Force along the x direction is 0. Means leftward force N2 by 2 balances the rightward force N1 √3 by 2. So N2 is equal to N1 √3. And force in y direction is 0. Means upward forces N2 √3 by 2 plus N1 by 2. They together balance the downward force 50. Solve these two equations. Get N2 from the first equation and put it in the second equation. You will get N1. And then you can tell N2 value also. Okay. So what we effectively did today is discuss some questions based on equilibrium. Fine. When net force acting on a system is 0, how to find out some of the unknown forces is what we did today. Okay. We considered normal forces to be acting. We considered tensions to be acting. Weight we anyway have to consider. That is not an option. Okay. So I'll send you a worksheet tomorrow with some more questions like this based on equilibrium. And you all will have a class tomorrow also. And we will be discussing maybe some more cases of equilibrium. And then we will move on to cases where the system is not in equilibrium. Means under the influence of one or more forces, a system accelerates. You have to find out the acceleration and then maybe find out something more about it based on the acceleration. Such question. We'll move on to such questions. Okay, so if any of you have any doubts based on today's class, you can ask. And tomorrow's class will be sometime during the day itself. I hope you all have a holiday tomorrow. So instead of in the evening, I'll take some time in the afternoon or maybe in the morning. Is 11 o'clock okay for all of you? 11 to 12:30. Tomorrow 11 to 12:30.
Sir, is somewhere after like 1 o'clock fine, 1 o'clock or something like that.
After 1 o'clock. Okay. So 1 to 2:30, is it fine?
Yeah, sir, that's fine.
Others?
Sir, like 10 to 11:30.
Okay. Fine, we'll do one thing. In this class, like your batch, I'll take 10 to 11:30 itself. Rishi, you will have to attend both classes tomorrow. Like 12th class session also I'm going to take.
Okay, sir.
So
No
my
problem.
plan was to take one in the morning and one in the noon. So the 12th class session I'll take from 1 to 2:30. You can attend that. And 11th class
Okay,
session,
sir.
I'll send you the recording. You will be able to see. Okay.
Yeah, sir. Okay, sir. Sure.
Fine. So for you all, there will be a class from 10 to 11:30 tomorrow. Is that fine? Others?
Yes.
Okay. Okay. So make a note of it. Tomorrow's class 10 to 11:30. It may like we may close the class before 11:30 also. It won't extend beyond that. Okay. Thank you all. We'll continue tomorrow.
Thank you, sir.
Thank you.